Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. How are you guys? Now I am going to discuss what very important topic, that is PN junction and BJT from EDC, right? I think now sound quality, picture quality, everything is fine. Yes, please check this. Okay, give me 1 minute only. हेलो, हाँ ठीक है. Okay, now is it audible, guys? Sound, Amrita. Okay then, everyone, now it is audible. Okay then, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi and it is a special 26 series and I am taking what very important topic, PN junction and BJT from EDC, and that is for GATE 2024. Okay, so Ankit sir with us and Meghna and all other students, very good evening. तो चलिए स्टार्ट करते हैं without any delay. Then guys, this is my introduction, 23 years of teaching experience. These are my ranks in engineering services exam. And now as you know, we have around what 50 days for GATE 2024. तो चलिए मैं आपसे क्वेश्चन पूछता हूँ, कैसी है आप लोगों की प्रिपरेशन? इज गोइंग वेल एवरीवन? ऑल आर हैप्पी? तो कौन कौन से टॉपिक है आज के? एंड दिस इज माय टेलीग्राम चैनल वेयर यू कैन फाइंड द पीडीएफ ऑफ दिस सेशन. I will upload the PDF of this session and previous session, that is on what semiconductor physics. Now remember, there are mainly 4 important topics. One is semiconductor physics, PN junction, BJT and what MOSFET with MOS capacitor. Special diodes, no doubt we are getting the question, but what about the questions, guys? We are getting what very formula based question from special diodes. Okay, then these are our results in engineering services exam. 5 under 10, 29 under 50, 37 under 100. If you want to give this type of results, then you can start your journey with us. And then this is what space charge is, and just without any delay I am going to start this topic. First of all, PN junction. In PN junction, get the idea about the space charge region, guys, right? Space, Rumi sir, how many questions are asked in this? 2 to 3 questions. Happy to see your activeness. Yes, everyone. देखिए पूरी टीम हमारे साथ है. अब आप लोग पूरे एक्टिव होकर इसमें पार्टिसिपेट कीजिए एंड गिव योर कमेंट्स ऑल्सो. ओके गाइज, 1 minute. I think my comments are visible to you. So देखिए, space charge region means what? This is called P type, this is called N type. Here we are having the immobile charge carriers. Here negative ions, that is called acceptor ion. Here it is positive ion, that is called donor ions. Right? Now we have field. What is the field here? Always remember, when we are giving the ND and NA doping, then there is a negative and positive charge. These are the ions. Means what? we are having electric field from positive to negative. This is positive and that is negative, and because of that electric field there is a potential barrier that will stop the diffusion of holes and stop the diffusion of what, electrons, so that in open circuit bar the current is zero. So now you have to get the idea about the field, guys. So that is the direction from right to left, and it will force the holes to move from n side to p side, and it will force the electron to move from n side to p side, and that's why that is zero, and that is the formula for the potential barrier. You have to revise this. Okay, then you have asked, sir, how many questions they will ask. Remember, PN junction we are getting 1 or 2 questions, minimum 2 marks, maximum what, up to 5 marks we can expect from that PN junction. Then BJT, sometimes we are getting question 2 marks question, or sometimes what, 4 marks question, guys. That's why these 2 topics are important. And you can say, sir, MOSFET is very, very important. Yes, semiconductor physics, PN junction, BJT, MOSFET and MOS capacitor, and sometimes we are getting questions from what, special diodes like solar cell and so on. Now I think this is clear to you. Okay then. तो हिंदी में पढ़ा है सर. ओके, मोहित कश्यप, हिंदी और इंग्लिश. This is a mixed language. So these are the acceptor ions, and that is what, donor ions. Now these are called uncovered ions. So please tell me what will be the answer for this type of questions. Everyone, क्या होगा आंसर भाई, जल्दी से बता दो. जैसे ऐसे जो क्वेश्चंस है ना, बेसिक क्वेश्चंस, वो आ सकते हैं इन एमएसक्यू. तो व्हेन वी आर गिविंग द डिप्लेशन लेयर अक्रॉस द पी पॉजिटिव एन जंक्शन लाइज, तो ऑलवेज रिमेंबर Na into Wp is equal to what, Nd into Wn. Na, P positive means Na is very, very, very greater than what, Nd, then Wp is very, very less than Wn. So where is the depletion width? Mainly in N region. So this type of questions you can expect. Yes. So equally in both and P region wrong. Mostly in N region, that is correct. That is correct. Right? Equally. No, that is not equally. Okay. Mohit, it is clear. Rajesh, it is clear. B is the answer. And that is the formula for that. This is the depletion width in P side, and that is the depletion width in N side. Now, this type of questions, very simple basic questions. Then second one, the depletion region in semiconductor PN junction diode has what we have in PN junction diode, the positive and negative ions on either sides, guys. And that is also correct. If it is MSQ, no holes. Yes, there is no mobile charge carriers, neither electrons nor ions. This is wrong. Electron and holes, that is also wrong. But it may be possible that there is no holes, only positive and negative ions on either side. I have chosen this question because of what, MSQ. Now this is in gate 2 marks question. In an uniformly doped abrupt PN junction, the doping level of N side is 4 times the doping level of P side. Doping level of N side is 4 times, means Nd is 4 times of Na on the P side. Or the ratio of the depletion layers width of the N side and P side. So that is the formula. Na into Wp is equal to what? Nd into Wn. So please read question carefully. Ratio of the depletion layer width of the N side versus P side. Wn by Wp. So Wn by Wp is equal to what? Na by Nd. What is the Nd? 1 by, this is 1 by 4. That is 0.25. What is the answer for this question? A. Very true. Very basic question, guys. Immobile hands and right. That is the answer. Then second important question is what is the effect of temperature on the voltage across the diode? That is, this is from the EDC. So when the temperature increases, drop across the diode decreases for constant current. Drop across the diode decreases. So what is the drop across? In the figure, silicon diode is carrying a constant current of 1 milliampere. That is the constant current. When the temperature of the diode is 20 degree, Vd is found to be 700. If the temperature rises to 40 degrees centigrade, what will be the Vd approximately? So it will decrease. That's why this answer is wrong. It will remain same. That is wrong. Means out of these two, one is correct. Now what is the change in the temperature from 20 to 40? Means it is changed by what? 20 degrees centigrade. So 20 degrees centigrade. So according to the textbook, In some textbook, change in the VD with respect to temperature, it is given minus 2.5 millivolt per degree centigrade. That is in Millman-Helkias, or in Cedra and Smith, it is given 2 millivolt per degree centigrade. So you can check with the, what is the change in the temperature? 20 to 40. So what is the change? 20. So when the 20 is multiplied with the 2.5, so it will be change is what? 50 degree. 50. So 50 means what? 700 minus 50 to 650, but 650 is not the answer. Now you can choose what? 2. So 20 into 2.0, that is the 40. So it is decreased by what? 40 millivolt. So 700 minus 40, which answer is correct? 660. This answer is correct, 660. Is it clear? 660, not C. C is not the answer. Okay, B, because we what is the change in the temperature? 20 degree. 20 multiplied with the 2, what is the change in the voltage? 40 millivolt. 700 minus 40 is what? 660. That's why this is the answer. So you will get this type of questions, guys. Okay, then next one. At 300 degree Kelvin, for a diode current of 1 milliampere, a certain germanium diode requires a forward bias of this one, whereas a certain silicon diode requires a forward bias of 0.718. Under the condition stated above, the closest approximation of the ratio of reverse saturation current in germanium diode to that in what? Silicon diode. Okay, so that is the question. You can say, sir, what is this forward bias of 0.4135, and they have the same current. They have the same current. Then what is the closest? So I'm giving you the hint. You can use this formula. Yes. Now, I is equal to I naught e raised to power V by eta Vt minus 1. That is the formula. A reverse saturation current, right? This is given as 1 milliampere. Okay, you can use. And for germanium, what is the V? So it is approximately, you can write I naught e raised to power V by eta Vt. And as you know, eta is 1 for germanium and eta is 2 for silicon. You can use this formula. If it is not, we are not getting the answer out of 4, then guys remember, you can use eta for both germanium and silicon, because for high current, it is what? 1. 300 degree Kelvin current is given, forward bias of 0.1435, whereas a certain silicon diode requires a forward bias of 0.718, right? Under this condition, what is the ratio of the reverse saturation current in germanium to that in what? Silicon. Always remember, germanium has in the range of what? Microampere, or silicon has in the range of what? Nanoampere, and that's why most probably the answer will be C or D. Most probably the answer will be C or D, but you have to find. So can you use this formula, everyone? Yes, use this formula. 1 milliampere is equal to I naught for germanium e raised to power. That formula is given 0.135 upon Vt, right? And then 1 is equal to I naught for silicon e raised to power 0.785, that is given 0.718 upon Vt, 2 Vt. For example, if you are writing, now you can divide these two, and when we are dividing these two, it will become I naught of germanium upon I naught of silicon e raised to power 0.4135 minus 0.718 upon Vt. You can find this is the negative value. This time it will become what? Positive value. So what is the germanium upon silicon? It will become divided by 2. This is divided by 2 also. Okay, and then on the right hand side it will become e raised to power 0.718 divided by 2 minus 0.1435 upon Vt. Vt is volt 300 degree Kelvin. You can put here 0.026. 0.026. Okay, use this formula and solve this question. Now, What is the answer? Tell me. Solve this question and give me what is the answer for this question. Everyone, use your virtual calculator. Use your virtual calculator. D, you are getting answer, everyone? Okay. Then next one. So guys, remember how to solve. Normally what we are getting the answer depends. You have idea that reverse saturation current, it is in microampere for germanium and nanoampere for silicon, and that ratio 10 to the power 3, and then remaining will give you the factor A4 and 8. So eta you can use the 2.4135 and subtract it, and e raised to power you have to find. You are getting C, तो C or D, it depends है ना. Formula में देख लो, check कर लेना. VT, what is the VT? Some students are confused with the VT. VT is 0.026 volt, because this is in volt, this is in volt, that should be in volt. Okay, if you are not getting the answer, then you can take the eta is equal to 1, because there are 4 options are given. If it is a numerical answer type question, then you have to use eta is equal to 2 for silicon and 1 for germanium. Okay, the first type of this type of questions. Second, what are the properties of the reverse saturation current, guys? What are the properties of the reverse saturation current? That is, it doubles for every 10 degree rise in temperature. So normally again from last 20 years it is silicon PN junction 20 degree has a reverse saturation current of 10 picoampere. The reverse saturation current at 40 degree centigrade for the same bias. So as you know, it doubles for every 10 degree rise in temperature. It doubles for every 10 degree rise in temperature. So what is the reverse saturation current at 40 degree? It is given by reverse saturation current at 20 degree 2 to the power 40 minus 20 divided by 10. So it will become, what is the reverse saturation current here? 10 picoampere into 2 to the power 2, that will become 40 picoampere. So it doubles for every 10 degree rise in temperature. B answer. B is the answer for this particular question. Very, very easy one. Now, next one. Next is, so already we have solved. Sometimes we are getting this type of question. Just for a quick revision, guys. This is based on what? Piecewise linear model, and that formula is given. So directly you can use this formula and then tell me what is the answer for this question. That I, the relation is given V minus 0.7 upon 500 when the V is greater than 0.7. V, what is V? Voltage across the diode. And when V is less than that, current is 0. But suppose the current is 0. That first case, if the current is 0, what is the drop across this? 0. So 10 volt will come across the diode, and then V will become what? 10 volt. And it is greater than what? 0.7 volt. Once it is greater than 0.7 volt means current is not 0. Current will follow this formula. When the current will follow this formula, V minus 0.7 upon 500, and that the current, it is in ampere. And answer is given in what? Milliampere. So first of all, convert it into milliampere. So when it is multiplied with the 1000 upon 500 into 1000, it is converted into what? Milliampere. So it will become 2 times of V minus 1.4. 2 times of V minus 1.4, and that is in milliampere. That is a relation in milliampere. Okay. Then what is the answer, everyone? So first of all, get the current, because the voltage across the diode is greater than 0.7, it will follow this formula and convert ampere into what? Milliampere, because answer is given in milliampere. Now, what is the current for this diagram? What is the current for this diagram? You have the two relation. One relation from this diagram, 10 minus V upon 1 kilo ohm. That is the value of I. You can write I is equal to 10 minus V upon 1K. That is in milliampere. And what is the I from the that diagram? That is the value 2V minus 1.4. 2V minus 1.4. Can you equate these two? Yes, we can equate. So 10 minus V is equal to what? 2V minus 1.4. So it will become 10 minus 1.4. 10 plus 1.4 is equal to what? 3V. So what is the V is equal to? 11.4 divided by 3. 11.4 divided by what? 3. Then it will become 3.8 volt. Watch this. What is the drop across the diode? 3.8 volt. Normally we are choosing what? 0.7 volt. So according to this question, it is 3.8 volt is the drop across the diode. And then what is the current? 10 minus 3.8 upon 1 kilo ohm. So current will become 10 minus 3.8 upon 1 kilo ohm. That is 6.2 milliampere. That is the current. That is the current. So directly you can solve this type of questions on a diode. So get the command over what? Piecewise linear model of the diode. Just I am giving what is the piecewise linear model of the diode. Remember, first of all, in 99% cases we are using the ideal diodes. Then second one is what? Practical diodes. And third one is what? More practical diodes. What is the more practical diode? देखो क्या होता है more practical diodes. First, ideal diode. That is this is the relation between I versus what? V. Second, 0.7 volt drop. They will give you this type of diagram. Then you have to choose the practical diode. And that drop is what? 0.7 volt. And third one is this one. So this is the V gamma or VD, drop across the diode cut in voltage, and that is what slope is 1 by Rf. So in the given question, that was the characteristics I versus V. This is 0.7 volt it is given. Before that the diode is off, current is 0, and after that it will follow this slope. Okay. So 6.2 milliampere is the answer for this question. They can give you the another question, what is the internal resistance of the diode? So you can find the internal resistance of the diode. For example, what is the drop across the diode? What is the drop? 3.8 milliampere. So diode can be replaced by this. What is the cut-in voltage? 0.7 volt. What is the internal resistance? Rf. And what is the current here? As you know, 6.2 milliampere. What is the total drop across the diode? Total drop across the diode is 3.8 volt. So what is the 3.8 volt? This 3.8 volt is given by 0.7 plus I into Rf. 0.7 plus I into Rf. Can you find the Rf? Then Rf will become 3.8 minus 0.7 upon I. So it will become 3.1 upon 6.2. That is 0.5 kilo ohm. Means what? It is a 500 ohm. This is the value of Rf. This is the value of Rf, internal resistance of the diode. They can ask, yes, this is a very high value of the Rf, 500 ohm. But directly you can say Rf is equal to. Why? Because in this diagram, what is the value of Rf? देख रहे हैं अब what is the equation of the line, equation of the current? So you can find the value of the current here, that as you know y is equal to what? Mx plus c. Mx plus c. So what is the equation given here? I is equal to V minus 0.7 upon 500. V minus 0.7 upon 500. You can write V upon 500 minus 0.7 upon 500. So this is nothing but V upon 500. So what is the slope here? Slope. is M is equal to 1 by 500 is equal to what? 1 by RF. So what is the RF here? RF is equal to 500 ohm because it is in ampere. Yes, in this way you can solve this question. Okay, so that is the value of what? RF. So चलिए ये है, that is about the diode. फिर we are getting the question on what? Transition capacitance and diffusion capacitance. That is very important topic, and please revise this topic. Diffusion capacitance, tau G. So this time you can expect one question from diffusion capacitance. When the diode is forward biased, there is a diffusion capacitance tau G. G is the incremental resistance, tau I by eta Vt. Tau I by eta Vt. That is the answer. Then second is diode reverse recovery time, storage time, transition time. So switching time you can revise, right? You can revise the switching time also. That is called storage time and what? Transition time. This is called reverse recovery time. Please revise this. In my one session I have given detailed idea about this transition time. So please everyone revise that. You can expect one question from that. Third one is what? Transition capacitance. Transition capacitance. अच्छा सर, आपका आज बायजूस ऐप में डिजिटल का प्रैक्टिस, अब कोई अमृता, नाउ देयर इज नो क्लास फॉर दैट. ओके, आई एम नॉट गोइंग टू टेक एनी फॉर नेक्स्ट 15 to 20 days. ओके, तो प्लीज रिवाइज ऑल दिस, एवरीवन रिवाइज ऑल दिस टॉपिक. तो ऐप में ना कोई ऐप, अच्छा लास्ट क्लास थी एक ऐप में, अब ऐप में क्लासेस शायद अब होगी नहीं है ना, फॉर अब जस्ट एग्जाम आ गया ना, तो जो भी होगा दैट इज ऑन यूट्यूब. So depletion capacitance of an abruptly PN junction with constant doping on either sides varies with reverse bias. So what is that formula? Cj is equal to what? V raised to power minus 1. Yeah, again 1 by root over VR. For next 5 to 10 days. After that they will start. Okay. Then ये हो गया. This is for what? Abrupt junction. And then for linearly graded junction it will become what? VR raised to power minus 1 by 3. VR raised to power minus 1 by 3. Then in an abrupt PN junction, the doping concentration on, this is a very very important question. NA&D PN junction is reverse biased, then the total depletion width 3, the depletion width on the P side. Already we have solved this type of questions, right? So you can solve this. NA into WP is equal to ND into what? WN. That is the formula you can use here. Same formula you can find the answer for this question. Then we are getting about the built-in potential. So when we are talking about the built-in potential, then remember Vj is given by built-in potential or V naught plus what? VR applied in the reverse direction, that is given by Qn upon 2 epsilon s into W square, where W is the WP plus WN, or 1 by N. N is equal to 1 by N is equal to 1 by Na plus 1 by Nd. Okay, 1 by Na plus 1 by Nd. That is the formula, guys. Okay, so you can use this formula to find the N. Now remember, we are using this formula, but there are two cases. When Na is very very greater than Nd, then WP is very very less than Wn. So this will become W is nearly equal to what? Wn, or N in this formula, N is nearly equal to what? Nd. N is nearly equal to Nd. Second, if Nd is very very greater than Na, that will be given in the question, then guys remember WP is very very greater than Wn. So W is nearly equal to WP or N is nearly equal to Na. You have to use this formula. So then you can solve any type of questions. Any type of questions based on what, or if they are comparable, Na and Nd are comparable, then you can use this formula directly. So that is given. Consider an abrupt PN junction. That is the formula for abrupt PN junction, and that is VBI plus VR. This is called junction voltage. It is given. This is called junction voltage. It is given. Okay. So remember, it is inversely proportional. That's why always in second case, CT2 upon CT1 is equal to root over VJ1 upon VJ2. Why opposite? Because it is inversely proportional. What is the VJ1? VBR plus VR, 1 volt, and this is the 4 volt. 1 by 4, that is 1 by 2. So that is the capacitance will become half of the previous value. If it is 1 picofarad, it will become what? 0.5 picofarad. Are you getting my point? This is a very, very important transition capacitance. Now, transition capacitance, use this formula. Then this diagram is also very important about the transition capacitance. About the transition capacitance, where we are going to get the maximum electric field exactly at junction. Exactly at junction we will get the maximum electric field. The maximum electric field is given 10 to the power 4, and this is the diagram. Which of one of the following statement is not true? That is question given, but in MSQ they can give which are the statements are true. That will become MSQ. So which are correct here? So that type of questions means what you can do? You can do one thing here, that first of all remember this. ठीक है, अभी आप प्लीज सब्सक्राइब द चैनल ऑल्सो, राइट? Classes will be continue on YouTube. We are taking this series, guys, and after January we are going to start some important session for you. So stay tuned with us, and within 2 or 4 days classes will be continue on app also, right? तो कुछ क्वेश्चन सॉल्व करो, कुछ रिवाइज करो, एंड फोकस्ड ऑन योर स्टडी, बिकॉज नाउ वी हैव अराउंड 50 days ओनली फॉर व्हाट गेट एग्जाम, और लेस देन दैट ना. और कैसी चल रही है आप लोगों की प्रिपरेशन? एवरीथिंग इज फाइन? तैयारी कर रहे हो ना आप लोग? Okay, then watch this. If this is the above and below, then always remember this. Normally we have for this Pn, this is the Na, this is what Nd. So here we are having the negative ions, here we are having the positive ions, and in depletion width on the N side is very, very high because the doping on the P side is very low. So because it is negative, so we are going to start with, and this is a uniformly doped, that's why this is the doping. That is the positive ion and that is on the negative side. Now when we are integrating, we are getting this type of diagram. This is the electric field, and that is the, according to Poisson's equations, right, as you know, d square v by dx square is equal to minus rho by epsilon, volume charge density, and so on. So at the junction we are getting the electric field. So on the left hand side, left hand side it is p type, on the right hand side it is n type. So we are getting this type, but what is here? It is just opposite. So when it is just opposite, means on the left side we have n type, on the right side we have p type. This is n, this is p type. These all are what? Negative ions. These all are positive ions. Okay, so this is n side, this is p side, and then electric field exactly at the junction we are getting the maximum electric field, and they are uniformly doped. There is a step grading. Suddenly the concentration will decrease, but on the P side it is uniformly doped, on the N side it is uniformly doped. That's why we are getting this type of concentration. Or what is the integration of the square type of shape? That is a triangular way. We are getting uniform doping. So first of all, left side of the junction is N type and right side is correct. Both N type and P type depletion region are uniformly doped. It is also correct, right? And then if the potential difference across the depletion region is 700 millivolt, if you want to find the potential difference, simply integrate it, because when we are integrating the electric field, you will get the potential, but negative potential, no doubt. What is the magnitude of that? Integration of E dot dx. Integration means what? Area of that. So what is the area? This is 1 minus 1, 0.1, 1.1, and what is the height? 10 to the power 4. Half of base into height. That will give you the electric field. But I think we are not getting the same electric field here. This is, remember, it is in volt per centimeter. And that is in what? Micrometer. That is in micrometer. So micrometer means what? 10 to the power minus 4. So you will get the 0.55 volt. Means what? 550 millivolt. That is the potential barrier. But here it is the 700 millivolt is given. This is wrong. And if the P-type region has a doping concentration of 10 to the power 15, and then the doping concentration in the N-type region will be 10 to the power 16. Correct. Why correct? Because it is Na into Wp is equal to Nd into Wn. Na into Wp is equal to Nd into Wn. Nd on the right hand side, 0.1, that is the depletion width. Here it is a 1. Here it is a 10 to the power 5. So what is the Nd? 15. So it will become 10 to the power 16. 10 to the power 16. And that's why this is also correct. So according to the answer, this is C is the correct answer. C is the correct answer. But if it is MSQ, then which are correct means ABD are correct. So this derivation is very, very important one. So I have done this derivation. Please go through it. ओके तो बहुत बढ़िया। अगर आपकी तैयारी चल रही है तो देखो, मैं आपको टॉपिक बता रहा हूँ, विद इन 1 आवर आपको समझ में आ जाएगा कौन कौन से टॉपिक इंपॉर्टेंट है। देखो कि लास्ट ईयर भी देखो क्वेश्चंस रिपीट नहीं होंगे दोस्तों, क्वेश्चंस कोई रिपीट नहीं कर रहा। तो क्या कर रहे हो? अच्छा अमृता, वाई यूनिफॉर्मली डोप्ड, अच्छा क्वेश्चन है, यूनिफॉर्मली डोप्ड क्यों है? एक मैं ये बताओ ना, मैं ये बोल रहा हूं कि दोनों साइड की डोपिंग यूनिफॉर्मली है। आप जैसे डेरिवेशन में देखोगे ना, तो इधर जैसे डोपिंग है, मेरे कहने का मतलब है यहां जो आपने Na की डोपिंग की है वो पूरी यूनिफॉर्म है, ये यूनिफॉर्म है। ऐसा नहीं है कि ये लीनियरली नीचे जा रहा है, एकदम बराबर बराबर है। और ये होल का कंसंट्रेशन पूरा यूनिफॉर्म इधर। लेकिन इधर आए तो आपने Nd की डोपिंग यूनिफॉर्म है, इधर Nd की डोपिंग यूनिफॉर्म है, ये इलेक्ट्रॉन्स है। अब ये कैसे पता चला? क्योंकि जब डिप्लेशन लेयर बनती है ना, तो इस टाइप का शेप आता है, स्क्वायर शेप। देखो ये जो है ना, ये जो है विड्थ, ये Wn है। जैसे अगर ये N साइड, ये जैसे P साइड है, तो ये Wp हो गया। ये वाली लेंथ है ना Wn शो करती है। और ये देखो यूनिफॉर्मली डोपिंग दिखा रहा है। व्हाट इज द यूनिफॉर्म डोपिंग? Na है, तो Na इंटू Wp इज इक्वल टू Nd इंटू Wn। ये Nd है, Nd इंटू Wn। यूनिफॉर्म डोपिंग में आपको कंसंट्रेशन आ रहा है ना, चार्ज। अब आया समझ में? और इसी का इंटीग्रेशन, जो स्क्वायर का इंटीग्रेशन कैसे दिखेगा? ट्रायंगुलर। और नेगेटिव से स्टार्ट हो रहा है, इसलिए पहले नेगेटिव जा रहा है फिर पॉजिटिव जा रहा है। तो ये इंटीग्रेशन, इलेक्ट्रिक फील्ड इसलिए एग्जैक्टली एट जंक्शन हमको मैक्सिमम मिल रही है। तो अकॉर्डिंग टू, तो ये डेरिवेशन जाइए, इसलिए मैंने कहा डेरिवेशन करो, ये वाले पूरा पॉइजन्स इक्वेशंस पे बाउंड्री कंडीशन के साथ डेरिवेशन करो। डेरिवेशन बहुत इंपॉर्टेंट है। देखो अलग अलग तरीके से क्वेश्चंस आते हैं, ये अच्छा क्वेश्चन है। इसमें अगर किसी ने डेरिवेशन नहीं किया है, इफ यू हैव नॉट डन द डेरिवेशन, देन इट विल बिकम डिफिकल्ट टू सॉल्व दिस टाइप ऑफ क्वेश्चंस। तो मेरा काम है थोड़ा सा जस्ट इंपॉर्टेंट पॉइंट्स बताना। तो दिस अगेन लास्ट ईयर सेम क्वेश्चन, यू कैन सॉल्व इट। So guys, this is a scholarship test, 90% off on our program, 24th of December, 9 AM to 9 PM, and very important workshop by Rakesh Talreja sir. So you can watch this, how to secure single digit rank in GATE 2025 from on 27th of December at 7:30 PM guys. Now, this is the question on switching time. So already I have given storage time and transition time. In the circuit shown below, the switch was connected to position 1 at t less than 0 and t0 changed to position 2. Assume that the diode has a 0 voltage drop and storage time ts. For this one, VR is given by. If you have idea about the storage time and transition time, during storage time again, the diode behaves like what? Short circuit. So when we are changing the position here, so up to storage time it will act as short circuit. So what is the voltage? Initially it was 5 volt, now it will become minus 5 volt. Then output voltage will become minus 5 volt. So what is given? During storage time, what is the VR? What is the output voltage VR? That is given by minus 5 volt. Answer. So for this type of questions, get the basic idea about what switching time, what is the storage time, what is the transition time, and so on. Go through the theory. We are getting question on this. Now, अब आता है sir, what is important in BJT? Important in BJT means what? First of all, the internal diagram, N-type, P-type, N-type, P-type, N-type, P-type. That is the symbol for NPN transistor, PNP transistor. And then you have the idea about the mode of operation, cutoff, active, saturation, and reverse active mode. Okay, get the applications. Then current component. Current component is important because in EDC, how we are going to get the IC is equal to alpha I plus what? ICO. That is important. This formula is important. Please remember that. And what is the ICO? ICO has the two component. One is called IPCO and INCO. This diagram is very, very important one. Then this is the condition. What is the forward bias? What is the reverse bias? On this diagram already we have one question. This is called charge control description of the diode. This diagram is based. When the diode is forward biased, according to law of junction, the concentration at this point increases, concentration of electron at this point increases. Now it will diffuse. Once the junction is reverse biased, what is the doping concentration or what is the concentration of electron and hole? It will become 0 when that particular junction is reverse biased. There is a depletion region, and in depletion region, what is the concentration of mobile charge carrier? 0. This junction is reverse biased, that junction is forward biased, because here we are having the excess hole concentration, excess electron concentration. Then we can say this transistor is in what? Active region. So that type of diagram is very, very important one. So already we have one question on that. Right, watch this. To watch this, in 2017, 1 mark set one question. Here we are having the excess. Excess means that collector junction. This is the collector, this is the base, this is the emitter. Means this junction is forward bias. And here we are having the deficiency of charge carrier. It will become 0. Then it is what? Reverse bias. When the collector junction is reverse bias, emitter junction is collector junction is forward bias, emitter junction is reverse bias. Means it is in reverse active mode. Forward active, inverse active mode. This is the answer. So watch this diagram and get the more detail about this diagram. More detail, because in 2017 only the introduction is given. This is the topic from what? Charge control description of the diode. Prepare this topic from EDC. Charge control description of the diode of BJT. Okay, in 2017 again we are having the question. So the inverse active mode, guys. Right, then remember in EDC, because in analog we are solving what? We are solving a question, but BJT, biasing and stabilization and so on. But in EDC, just get the idea about the internal. What is this? Alpha. The small signal or sinusoidal common base current gain is defined as. So what is this? This term and third term. 1, 2, 3 terms. So 1, 2, 3 terms are emitter injection efficiency, base transport factor, and recombination factor. When we are multiplying the emitter injection efficiency, base transport factor, recombination factor, then we are getting overall alpha. Overall alpha. When we are multiplying this, alpha T and what? That. So this is the product of these 3, alpha. So right. So you please revise this formula so that you will get the basic idea about that. And last one is what? early effect, base width modulation. We are getting the question from early effect or what? Base width modulation. And because of early effect, alpha increases, base current decreases because recombination decreases, right? And collector current increases, emitter current increases because of diffusion, because it is a diffusion current, concentration gradient increases. And last one is what? Punch through or reach through. When we are increasing more and more VCB, depletion layer will increase and complete base region is depleted of mobile charge carrier. That is called punch through or reach through. So please read about this. They will ask in MSQ theoretical as well as numerical based question, base width, early effect or base width modulation, guys. Okay. And this type of questions they will ask. The phenomena known as early effect in bipolar transistor refers to a reduction of the effective base width caused by electron hole recombination, reverse biasing of the base collector, forward biasing of the emitter base junction. Thirdly, reverse biasing of the base collector junction region. So it is a very basic question. It is a very basic questions, but you will get more advanced question on this topic. What is the, how we can find the slope of the curve by using the early effect and so on. So that is a very basic question on transistor. So that is a part of EDC. And then last year this type of, in 2016, that is the question. That is the question. This junction is forward biased because we are having the excess charge carrier here. And at this point again it will become 0. Means if this junction is reverse biased, that junction is forward biased. Means what? That is in active region. And what is that? The injected excess electron concentration profile in the base region of NP and BJT biased in active region is linear. If the area of the emitter base junction is this one, mu n is given and depletion layer width are negligible, then the collector current at room temperature is given by. So remember guys, when the emitter junction is forward biased, mainly all the current is because of what? Diffusion phenomena. So for diffusion phenomena, collector current is nearly equal to emitter current is given by, because it is an electron, q dn dn by dx. Q dn dn by dx. Dn is the diffusion coefficient, and according to Einstein equation, dn by mu n is equal to what? Vt. So what is the dn? Mu n Vt. Now what is the dn by dx? You can find the concentration gradient. This is given, this is given. You can find the concentration gradient. This is the 10 to the power 14, here it is 0. So this will become 0 minus 10 to the power 14 upon, what is the length? 0.5 micrometer. 0.5 into 10 to the power minus 4, that will become micrometer. So it will become 2 into 10 to the power 18. So this is called dn by dx. So you can say what is the unit of that? Centimeter raised to power minus 4. Minus 2 into 10 to the power 18. It is negative because current will move in opposite direction. Now you can put this value here. What is the Q? 1.6 into 10 raised to power minus 19. What is the dn? Dn is mu n Vt. What is the mu n? 800. Vt is 0.026. 26 millivolt into, that is the concentration gradient, minus 2 into 10 to the power 18. Now can you find these values, everyone? Now this will become very easy. You can use your virtual calculator. But remember, that will give you the value of IC. So what is the direction of the IC? Electron will move from higher concentration to lower concentration, but the current will move in opposite direction, and that's why this is right direction of the IC is given. So IC will be positive. Here you will get the negative answer because of the formula. Because of the formula you will get the negative answer, but remember, it will move in the direction opposite to that. So फिर formula, what is the meaning of the formula? It represents current in x direction, but current is not in x direction. Current in x direction is should be positive. If we are getting the negative current, means it is moving in minus x direction. Minus x direction. Minus x direction, right? So minus x direction means what? That current is negative. But IC is given in the minus x direction. That's why you will get the positive answer. So take care of what sign, that is important. तो फॉर्मूला यूज कर लोगे, बना लोगे, लेकिन गलत आंसर आ जाएगा. प्लीज प्रिपेयर ऑल दिस टाइप ऑफ टॉपिक्स फ्रॉम दैट and prepare all the characteristics of common emitter, common collector and common base. For example, this is the characteristics of common base, right? So common emitter and common collector, guys, and get the idea about all the property of the common emitter, common base. Then, and just please note the topic. फॉर्मूला भी पॉजिटिव आया, फॉर्मूला भी में भी पॉजिटिव नहीं, फॉर्मूला में पॉजिटिव था, लेकिन व्हाट इज द dn by dx स्लोप? dn by dx स्लोप इज व्हाट? नेगेटिव ना. तो फॉर्मूला तो पॉजिटिव है लेकिन स्लोप इज नेगेटिव. तो मींस इलेक्ट्रॉन इज मूविंग इन x डायरेक्शन. व्हाट अबाउट द करंट? करंट इज मूविंग इन -x डायरेक्शन. बट ऑलरेडी यू हैव given the direction in what? Negative x direction, I see, and that's why ultimately answer is what? Positive. Answer will be positive, guys. So please note the topic. Breakdown voltages are also important. Basic idea: BV CEO, BV CBO, these two topics. Ebers-Moll model, revise Ebers-Moll model. Just quickly you can revise it. Ebers-Moll model. Switching time of the diodes, already I have given you the idea. And characteristics of common emitter, common collector and common base. So guys, this is the, you can install the BYJU'S exam prep from Google Play Store, leaderboard, students, and you will get the idea about the number of participants, what is your score, what is your rank. And guys, remember, GATE 2024 crash course, 2025 and 2026 vision course is going on. You can join that. For more detail, you can call at this number. For more detail, you can call at this number. Live classes, recorded lecture, study material, practice quizzes, mock test, everything is here. And you can continue your preparation with us. Hope you are enjoying. Sir, dn by dx भी तो positive कैसे आ जाएगा? How you are going to get the positive dn by dx? For example, suppose, tell me, this is decreasing like this. Tell me what is this slope, positive or negative? In normal case, we are moving in x direction. So this slope is what, positive or negative? Here this is the 10 to the power 14. Here it is 0. So what is the slope? Negative, na? y2 minus y1 upon x2 minus x1. y2 minus y1 upon x2 minus x1. What is this slope? Negative. In this formula, we are using, when we are writing that j and, this is the A, you have to use A also, IN, AJN. What is this? A, area, Q, dP, dn by dx. This is the formula. What is the meaning of this? When we are putting the dn by dx negative, you will get negative answer. What is the meaning of the negative answer? Electron is moving from higher concentration to lower concentration. It will move from, electron is moving in this direction. But because we are getting the numerical value negative, current is moving in this direction, negative x direction. Is it clear? This is the positive. In a formula it is positive, it is given, but we are getting the dn by dx negative. So overall numerical value you will get the negative, means it is in a negative x direction. For example, you are getting minus 2 milliampere. What is the meaning of this minus 2 milliampere? Minus 2 milliampere is in negative x direction, in this direction 2 milliampere. Electron is moving from higher concentration to lower here. And similarly for holes, we are having, for example, what is the current for holes? AJP, AQ dP by dx with negative sign. But if you are, this is the higher concentration, lower concentration, this is the holes. So you will get dP by dx negative. So negative, it will become positive and you will get the answer 2 milliampere. What is the meaning of the positive answer? Positive answer means what? Hole is moving in this direction, current is also moving in this direction. Now it is clear? Okay, then that's why I have chosen now, because we are doing the silly mistake. Get the command over this. Get the command over this, because negative positive answer will be wrong. Okay then, hope you have enjoyed the session, guys. This is my Telegram channel. Join everyone, Electronics by Sanjay Rathi. and put your comments there. And if you have any doubts, then I am here to solve your doubt. PDF, notes, anything. तो पूरे मोटिवेशन के साथ अपनी तैयारी कंटिन्यू कीजिए, और कुछ भी आपको दिक्कत है या कोई भी कमेंट्स लिखना है तो ऑन माय टेलीग्राम चैनल. So finally, you are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel, guys. And good luck for all coming exams. Thank you.